In section 3.1, we're going to look at some definitions for polynomials, leading towards our work for adding and subtracting polynomials, expressions, and functions. So first of all, some definitions. Okay, the first one up here is monomial. And so a monomial is a polynomial that is a product of numbers or variables which are raised to whole number powers. So it's really just a single term. So I guess that's the key right here. It's a single term. It's one term. And a term itself can be a product, but not a sum, right? It's just a single term. So these are all monomials right here because they are products of numbers and variables which may be raised to powers. Okay. Now the pieces of your monomial are the coefficient, which is the numerical multiplier, and the degree, which is the exponents on the variables. So just listing off some coefficients and degrees from these monomials here, or these terms here. So this term, any term by itself is a monomial. So this term has a coefficient of 6 and a degree of 5. So the coefficient is the number, 6, and the degree is the variable's power, 5. We can actually see it now that I highlighted it, but hopefully you know it was there still. Alright, so the coefficient in the next one. Coefficient is a numeric multiplier. So it's a number outside of the variable being multiplied by it. There isn't one right here, so it's an invisible 1. So you assume that it's 1 if it's not listed, so the coefficient is 1 there. And then the degree. Okay, so the degree is the exponent if there's an exponent by itself, but notice back up here, it is the sum of exponents if there's more than one variable. So we only use that sum piece if there's more than one variable. So the degree here would be 2 plus 4 is 6. Because there's more than one variable. The degree of that term is 6. Alright, the coefficient of the next monomial, negative 8n, is negative 8. And the degree. There's only one n there, so again, the 1 is invisible. It's just how many n's you had. So the degree is 1 because there's one n present. The last one, if the term is just numeric, 5, the coefficient is still 5 because that's the number. The degree, if you see an n, there's one of them. If there aren't any variables, there are 0 variables. The degree is 0 for a constant for a numeric only term. It has degree 0. So no variable. Alright, some more definitions. Let's look at the next set. We've got polynomial. A polynomial is a sum of monomial terms. The leading coefficient, so we already saw coefficient up here. The leading coefficient is the coefficient of the highest degree term. That's going to be important there because leading seems to say first, but they might not always be in descending order. They have to be in descending order for leading to be first. It's the highest degree term. Also, the degree of the polynomial is the degree of the highest degree term. Okay, so we'll check for order as we look through these. My polynomial is in descending order because the highest power is first. So when I want to talk about its leading coefficient and its degree, I'm going to be looking at that first term. The leading coefficient is 2, and the degree is 3. Coefficient is 2, degree is the power is 3. Okay, in the next one, this polynomial is not in descending order. So the leading term is the term on the highest power. If I was to rewrite that in descending order, it would start off with negative x squared minus 6x plus 7. So the leading coefficient is negative 1 from that negative x, and the degree is 2. I don't have to rewrite it to know that. I have to scan through and look for the highest power to get my leading coefficient and my degree. We prefer it written in that order anyway, though. Okay. Now, it gets a little more complicated when you have more than one variable because to find out the highest or leading term, you need to figure out the highest power and you need to add up the variables. So this one has a degree of 3. This one has a degree of 3 plus 1 is 4. This one has a degree of 2. This is a degree of 0. So if I scan through and add up the powers in the variables, the leading term should be the 5x cubed plus y. So the leading coefficient is 5, and the degree is 4. So back again, we're looking at the highest degree term to tell us the leading coefficient and the degree of the whole polynomial are. It's that highest degree term. I might have to scan through it to find it. And then this one again is just not written in descending order, just showing us, we have to look for it sometimes. Sometimes they're nice and already in order. We prefer that. It happens often, but not always. So the leading coefficient here is 4, and the degree is 3. Okay. Polynomials, like it says in the bottom, are often written in descending order, and we say thank you when they are. If they're not, it's often our job to make sure they're rewritten in descending order so the exponents decrease from left to right. So in this last one, if we rewrote it in descending order, it would be 4x cubed minus 9x squared minus 10. First term is positive, the other two are negative. All right, next page. A polynomial of degree 1, okay, if it has degree 1, not the same thing as having one term was a monomial, but degree 1, highest power being 1, is linear. We've already dealt with linear polynomials before. If they only have x, no x squareds, they're linear. Okay, if it has degree 2, not talking about terms, but the x being of degree 2, of power 2, squared, x squared, is going to be quadratic. And then degree 3, cubic. They do have names for a few more. We're going to focus with these 3. If you go into degree 4, it's called quartic, degree 5, quintic. There are a few other names. We're mostly going to be saying linear, quadratic, and cubic polynomials. Okay. So we're going to first take some expressions right here, rewrite them in descending order, identify their degree, and then just classify them as what kind of polynomial they are. All right. So not in descending order, so I'm going to rewrite this one to have its leading term first. That's the x squared term. So negative x squared plus 3x. It has a degree 2, and so because it has degree 2, the highest power, this is called quadratic. The next one, by the way, we don't use words like cubic, linear, or quadratic for the mixed variable problems, the problems that have x's and y's. This is only for the single variable problems, in case you were wondering. So these all have just x's. Okay, so this next one has highest power on that second term. So if I rewrote it in descending order, it's going to have negative 4x to the 5th first, then the minus x to the 4th, then the plus 2x cubed, then the plus 3x, then the minus 6. It has degree 5, and so we're going to say out of the 3 options, linear, quadratic, and cubic, it's none of those. It has degree 5, it's quintic if you want a word for it, but it's not one of the ones we're going to be focusing on in this class. It's got too high powers. Right, and our last one in this table, let's tell you highest power is that last term in this one. It is 10x cubed plus 8x squared plus 6, degree 3, highest power is 3, so it's a cubic. Okay. Last set of definitions. Now this one's about terms. Okay, so a polynomial with exactly one term. We mentioned this in the previous page, the first definition actually. One term meant that it was a monomial. 2 terms, binomial. 3 terms, I'm sure you can guess at this point, trinomial. And if it has more than 3 terms, trinomial. More than 3 terms at this point, we just call it a polynomial. There's also a case where it might not be a polynomial, so we'll see some of those as well. So if we had more than 3 terms, none of these have more than 3 terms. If it did, we would just put polynomial as an extra box in the end, called a polynomial. Okay. So these all have 3 terms or less. They're going to be monomials, binomials, or trinomials, or they might not be polynomials. So we'll have to think about what that means when we get to some that we don't think are. So let's see. This is just check boxes. So 1, 2, 3 terms, trinomial. If I wanted to give it more names, this trinomial happens to be a quadratic trinomial. So just as a note, right? Sometimes you might be asked to make up a quadratic trinomial. So it's going to have a power 2 and have 3 terms. So that's another definition name we could put on it. Okay, this thing has 2 terms, so it's a binomial. It happens to be a linear binomial because the highest power is just x. This has 1 term, so it's a monomial. It happens to be a quadratic monomial. Apparently I'm feeling like going above and beyond on my explanation here. I get the extra info, although it's just supposed to be check. Okay. I'm going to get down to this next one. It looks a little different because I have 5 divided by x squared over here. The definition of the monomial was a product. Remember, these have to be products of numbers and variables. That divide by a variable doesn't fit the definition. This one is not a polynomial. I cannot have variables in the denominators. Okay. Oops. And then when I get to the next one, this one looks normal again. It has 3 terms. It's a trinomial, and it happens to be cubic. If you want to, might as well continue labeling all these just for fun. That one's a cubic trinomial because the highest power is 3. So you can write quadratics as trinomials or monomials or binomials. You can write cubics as binomials or monomials or trinomials, or even with 4 terms, this is a polynomial. So they can be of all sorts of shapes. So we've got to have names to talk about how many terms they have and what the degree is, so we can develop processes for dealing with that.